Hi, good day, maayong adlaw. This is your Sir Carlo Trosio, and in this video discussion, we'll be learning the last lesson in our grade 11 statistics and probability, which is the regression analysis. Let us begin. Let us discuss this very simple concept all about predictions. For sure, you have had predictions that somehow unexpectedly it came true. For instance, you have counted the number of clouds in the sky, and that made you predict that it's going to be a rainy day tonight. Or the number of high scores that you get from your exams or your quizzes made you predict that you're going to be a with high honor this semester. Or the number of heart reactions that you get from your crush and made you predict that one day you're going to be her boyfriend or his girlfriend one day. Those are some examples of predictions. And here in statistics, with the data at hand and the correlation between variables, you can somehow predict what will happen in the future. For example, in the population in the Philippines, we have here a linear graph from 1975 to 2020. It kept on increasing. So, the statisticians can also predict with this data that we have that it's going to increase in a certain amount of number. For example, we predict 2025. So, we can predict it using statistical treatment, which we call the regression analysis. That's the power of statistics. Or you would want to know the Philippine economic growth and its progress. Is it going down or going up? As you may have observed, I think the inflation rate is going up in our scenario right now. So, with this data that we have, then we can predict maybe next year, I don't know what will happen. Maybe the inflation rate becomes more higher. That's so sad. Or in 2050, what will happen in our climate, in our Mother Earth? Probably will be too hot in here, or I don't know what will happen. But based on our observations, the El Nino, the one that we're experiencing right now, made us somehow conclude that one day we'll have that severe heat index in 2050. Well, of course, if you notice that most of the students or most of us are using the AI, or probably one day we hypothesize or predict that in 2050 will be run by robots or AI. So those are just the predictions that we have because we have the data at hand. But with the use of statistical treatments, we can further analyze the further outcomes of what will happen in the future. With that, let us begin our discussion. Very simple, all about regression analysis. Let this be your guide in answering the activity later on. So our learning targets are predict the value of the dependent variable given the value of the independent variable. So we'll be going back to the dependent and independent variable later on, which is denoted by X and Y. And we'll be presenting word problems involving regression analysis so that you will know how to use it in your research paper. Let us have a review in our lesson on Pearson R. We know that there are two major types of correlation. You have the positive correlation and negative correlation. The positive correlation states that both variables increase. For example, the higher the technology investment that you get, then the higher also the profit or the profitable growth. They both go in a one direction. Okay, that is a positive correlation. Upper right. Well, for this example, years of experience. So they say the longer you are in the workplace, or no, the higher the length of the years experience, then the higher the salary. That is true, but not true to all, of course. But we know that is the common. Okay, so what have you observed? Both of the data increased. Therefore, this is of positive correlation. Okay? How about this graph here? This is the law of supply and demand. So, the more demand, or the more, should I say, the more quantity or the more supply that you have, the higher. Okay, hold on. This is some sort of demand, no? If the demand is decreasing, then the price is, does it mean increasing? Basta something to do with decreasing and increasing. Okay? Or should I say, the higher the supply, the many the supply are, then the price decreases. Okay, so something like that. So that forms a negative correlation because there is contradiction between variables. Okay, so much to that one. So we have the meaning of correlation. No? Co means together, relation means connection. Independent variable can affect the dependent variable, and we can predict later on. Okay, so correlation describes strength of association between variables A and B, or B and A. So this time we denote Y as the dependent variable. Dependent, someone that or something that can be affected by the independent variable, which is X. Take note. Therefore, the regression analysis can be used if you try to go back to our example in population. Look at here. This one. How does the graph look like? It looks like a linear graph. It goes up to the right. It's a positive linear graph. And if you can still recall, the formula of the linear graph or the linear equation is y equals mx plus b, where m is the slope and b is the value of the y-intercept. This time we'll be using a and b, in which a is the slope and b is the value of y-intercept. Take note on that. With that, okay, we will be using this formula. This formula, a and b, take note, what is a? A is the slope. In this case, we'll be using b as the slope and a as the value of the intercept. And we know that there are ways on how you manipulate the computations. As what you have observed, this is somehow similar to the Pearson R coefficient formula, right? So what we did is we only manipulated, we transferred, transposed, and whatsoever. Then we have come up with this formula. Okay, but later on you will know how quick it is in the Microsoft Excel. Okay. So you have, again, B is the slope. Again, what is slope? The steepness of the line. How it rises and how it runs to the right. Now A is the intercept that belongs to the y-axis, no? Where the line starts progressing. Okay, kindly take note of the formula and we'll be using that later on. So let us begin directly with the word problems. Let us all read this. So you have these scores of the students, and basing on the independent variable, which is the number of study hours. So they said that the more you study, the more you get high scores, which is true. And as you may have observed here, the data are going up. You have 5, 7, 8, 11, and 13. It's going up. Well, the other one is also going up. 83, 87, 89, 93, 96. Therefore, you can only use, take note, you can only use regression analysis if the two variables are congruently increasing. They are both increasing, or positive correlation. Okay? So, with that, we'll use the regression analysis. Now, our main goal here is to find the score of the student if he or she studies for 14 hours. Imagine 14 hours of studying a day. So, let us predict what is the score of this student who studied 14 hours, since we do not have the data. But we have the set of data which can lead us to predicting using this method, regression analysis. We'll be right back with this problem later on. So what are the steps? The same steps as we used in the Pearson R correlation. We need to find the sums of x, sums of y, sums of xy, and sums of x squared. So what you're going to do is just indicate in the table the first, the x's and the y's. Okay, you have it here. There are 5 pairs. 5 is to 83, 7 is to 87. You add them all, you have the sum of x's, 44, sum of y's for 448. Then you also add, you multiply, you have 5 times 83, that is 415. 87 times 7 is 609, and so on. Then you add them all, then you have the summation of 4007. The same also with the x squared, no? Since you have x here, 5 times 5, that is 25, and so on, then you add them. So we now have the data that we are going to use for the formula. So where did we get the n is equal to 5? Okay, correct. So you got it from the number of respondents that you have. Okay, so these are the data that we need: summation of x, summation of y, summation of x times y, summation of x squared, and so on. Okay, with that, we'll be using the formula. Again, what is the formula? Y is equal to a plus b times x, where b is the slope of the line and a is the y-intercept. So this time, what is a? A is the value of the y-intercept. We'll be looking for the answers later on. So again, the formula is ready, and all you need to do is to substitute the variables that you have. You have e sub y is here, 448. You have the summation of x squared. You multiply them and you operate on them, and you can use calculator. That's it. That's the y-intercept. Next is we look for the slope of the line. So you have this formula again, okay? So n, what is n? N is the number of respondents. So you have, how many respondents you have? You have 5. So you multiply 5 by the summation of the products of x times y, and so on, so forth. So when you multiply them, just use the PEMDAS and everything's going to be correctly done. Okay, so you have 4007 times 5 minus 44 times, so you multiply them first, no, before you subtract it. In all over, divide, and that's it. Shortcut, because I know you know it very well how to do it. That's 1.583. What's this 1.583 10 thousandths or thousandths? That is the slope of the line. So with that, we were able to find out the slope. Again, what is the original formula? You have y-intercept equals letter A, which is the value of the y-intercept, plus B, what is B? B is the slope of the line times x, where the slope is 1.583 and y-intercept is 75.667. Therefore, we can now use the value which we are looking for earlier, which is 14. So again, the main question that we have is, what if the student studied 14 hours? What will be her or his scores in our just estimation? So with that, we can use the formula that we had computed. So how? Again, let us go back. Let us recap before we proceed. Again, step 1, comply all the needed values. We have the n, summation of x, y, x times y, x squared. You have that. Then find for the value of a. What's a again? A is the y-intercept. Once you find the value of y-intercept and also the b, which is the slope, then substitute a and b in the original formula. This one, the original formula. Okay. And you are left with letter x, or variable x. What is variable x again? Was that the independent or dependent variable? So you have the independent variable. So let us see what is the dependent variable for that data. Okay, so very simple. You are just going to substitute the 14 to the equation. You have here x substituted 14. 14 times 1.583. The product should be added to 75.667 thousandths, and you have the answer 97.829. Okay, so you have the predictions now. So therefore, if the student studied 14 hours, then he will get a score of 97.829 thousandths. Easy as that. Okay, that's the power of statistics. How about this? That we have the problem number 2. Let us read and analyze the problem. These are the actual data of the population of Cebu City as of 2024. So you have the population summing up to 1,043,000. So daghan na kita, no? From 2020, that is only 980,000, and this year 1,043,000. Okay, now we are tasked to guess or to predict what could be the population next year given the data that we have. So again, we'll be using the regression analysis this time. Okay, but this time we'll be using the Microsoft Excel for us to make our work easier. But just to go back to the steps again, no? You need to find first the values of the summation of x, y, xy, and the x squared. Once you find those values, then substitute that to find the values of a and b. What is a again? A is the y-intercept, b is the slope. Once you find the slope and the y-intercept, you substitute it in the formula y is equal to a plus b's x. Then you will be able to substitute the independent variable, which is this time 2025. This time let us go and utilize the Microsoft Excel. Okay, let me pause it. Okay, let us proceed with the prediction of the population next year, 2005. First of all, we need to find the b. Okay, the formula is a little bit mixed up, but it's a plus bx. Okay, no matter what, no, it's just a matter of, So a is the y-intercept and b is the, what did it call b? B is the slope Basta, the variable that is paired to x, that is the slope. So let me label it here slope, or what's that? Letter B, and the y-intercept, which is A. Okay? So the formula is very easy. Just click equals slope, and you will be able to find the slope. Okay? Slope, and then the y's. What are the y's? The population, no? Which is the dependent variable. Just highlight everything, comma, and the x's, which are from 2024 to 2020. The slope is 15,700, while the y-intercept, very simple formula again. So you have intercept, just click that one, and the same, just highlight the y's and highlight the x's, and that is your y-intercept. Okay? Now it's time to substitute it in the formula. So you have equals A is this, plus open parenthesis, you have B, which is this, times 2025, since we're looking for 2025, and click equals. There you go. This is now the estimated value or the population in the year 2025. From 104,000, from 1,043,000, it is now 1,000,000. What is it? 57,300. So, right? The regression analysis is really amazing, especially when you are using the Microsoft Excel. Okay? Did you get it? Okay, very good. That's it. How about if we check our work earlier in the problem number 1? Let us try to use Excel this time to make our work easier. So you have y plus b times x. So again, A is the y-intercept, B is the slope. So A is y-intercept. So the formula for A is intercept. So again, just highlight the y's, comma, the x's, enter. That is our, did we got it right? Yes, we did. That's 75.667 and so on. And you have slope equals slope y's and comma x's, enter. Oh, we got it right too. You have 1.583 hundredths and so on. So it's time to substitute in the formula. It's really easy, right? So you have A plus open parenthesis times B times, that's asterisk, times, what is the number of hours that we are looking for? You have 14. Okay, you have 14, enter. Okay, we have the same result as what we did in mano-mano or manually, and the same result as well with the Microsoft Excel. No, which one is faster? Of course, the Microsoft Excel is faster in computing the regression analysis. Okay, so I hope everything is clear so that we can proceed with the next part, which is the activity number 1 and activity number 2. Let me have it full screen. Okay, so this will be your task. Okay, you have 2 activities. You have activity number 1 and activity number 2. So activity number 1 is more on the number of days spent in vacation and the money that you are going to allot if depending on the number of days that you're spending in your vacation. So the question is, how much money will be spent if you will stay at Baguio City for 1 week? So you can estimate, no? You can estimate, okay, for 1 week. That's for 7 days. And for activity number 2, that is all about the number of appliances available at home the highest is 14, while the monthly electricity bill in Philippine peso is the highest is 2,470. Again, just a note, you can use regression analysis again if the two variables are in positive correlation. It cannot be used in negative correlation. Okay. So your task in activity number 2 is to predict the monthly electric bill of a household with 17 appliances. Okay. So that's it. Okay. Okay, I guess that will be all for this discussion in regression analysis. And again, of analysis is all about predicting the future outcomes or what will happen in the future given the data that you have in positive correlation at hand. Always remember that in statistics and probability, from the word probability, probable, it's just a matter of exact estimation. We are just estimating things here which are very close to the reality. That is the power of statistics. That's it, and thank you so much. Goodbye.